Okay, this set of problems deals with using sine, cosine, and tangent ratios. We have a page bundled into the packet just before this page. Let me go up to it, which is a set of trigonometry tables of sine, cosine, and tangent for all the angles from 1 to 89 degrees. And if we want to find tangent of 10 degrees, we go down to 10, go to the tangent column, 0.1763. Let's say we had that the cosine of an angle was 0.4540. Then we would go down the cosine column until we found 0.4540, which is this one right here. And the cosine of, if the cosine of an angle is 0.4540, that angle must be 63 degrees. Similarly, if you had a sine ratio of 0.9063, then that would go with a 65-degree angle. If you had a 2:460 tangent ratio, then that would correspond with a 66-degree angle. So we can actually kind of use the columns, the values in the columns, to look up the angle, or if we know the angle, we can find the angle and then use the columns to come up with the decimal ratio for the sine, cosine, or tangent. So let's get started on these. It says use the diagram to express the ratio as a fraction. So we're talking about sine of A. Now A is our reference angle. So if A is our reference angle, first thing I always do is find the hypotenuse, because that's ruled out of the thing. Now we have to decide whether we have an opposite or adjacent going on with the two remaining sides once we've identified the hypotenuse. And if we're at A, we can actually touch this side here, so this makes this the adjacent side, and it makes this side the opposite side. So for the ones with angle A, we're basically going to use this setup for side lengths. So let's do those first. So sine of A, sine is opposite over hypotenuse. Remember, we got SOHCAHTOA, S-O-H, C-A-H, T-O-A. Sine is opposite over hypotenuse. Opposite side is 12. Hypotenuse is 13. We have 12 over 13 for the sine of A. Cosine of A. Cosine, now cosine is adjacent with hypotenuse. Here's A. The adjacent side is a 5. Hypotenuse is a 13. And tangent of A. Tangent is opposite over hypotenuse. Should be an H. Excuse me. And we have opposite over adjacent. So A is our reference. Opposite is 12. Adjacent is 5. So if we turn these into a decimal, we could go to our table and find the actual angle measure. Like this would be an easy one to do. If I do 12 divided by 5, that's going to be 2.4. So, and it's a tangent. So if I go up to 2.4 on my table in the tangent column, find the closest one, 2.4, this is 751 away. This is like 4 something away. This is the closest one. It's close to, it's a little bit more than 67 degrees for that angle measure. That's how I can use the table. So if I needed to find the angle, it's around 67 degrees. We don't have to do that for these, but that's how the table would be used. We'll do that on the next section. Now we're talking about angle B. So let me erase what we have for adjacent and opposite. And now we're going to use angle B as our reference angle. So let me switch colors up. So now we're using angle B. So we still got the hypotenuse. Now 12 is the adjacent side and 5 is the opposite side, using B as our reference. So we want cosine of B. We're talking about, again, adjacent over hypotenuse. Adjacent is 12, hypotenuse is 13. Notice that the sine of A is the same thing as the cosine of B. You're using opposite angles, so adjacent and opposite switch places. Let's look at 5, tangent of B. Tangent is opposite over adjacent. The opposite side to B is a 5. The adjacent side is a 12. 5 over 12. And sine of B is opposite over hypotenuse. We have 5 over 13. So 5 over 13 is that one. Let's move up. We can use scientific calculator if you have one. You put 3 and then hit your sine key, or sine and then put your 3 in, depending on the order of operations, and then hit enter. Or we can use the table. For our purposes, we're going to use the table, which is this one up here. So we're going to find the sine of 3 degrees. If I go back up here to 3 degrees, and I look over to the sine column, it's 0.0523. Number 8, cosine of 30 degrees. So we're going to go to the 30 degrees. Cosine column is the middle. It's 0.8660. Tangent 45 degrees. We're going to find 48 and go to our tangent column. So 48's up here. Go to our tangent column, 1.1106. Sine of 79 degrees. We're going to go to 79 degrees into the sine column. Here's 79. The sine column is the first column. So we have 0.9816. Okay, now for number 11, we want to find what angle goes with the cosine being close to, or approximately, 9455. So we're going to go to our table, look down the cosine column, and find the closest angle that goes with 0.9455. So go to our table, cosine column's in the middle, we're looking for 9455. Right here, 19 degrees goes with cosine 0.9455. It's 19 degrees. Sine of some angle comes out to be 0.8746. We're going to go to our table, look in the sine column, find the closest angle to 0.8746. So sine is the first column. We're looking for 8746 right here, 61 degrees. For 13, we're looking for an angle that goes with the tangent of 4751, of 2.4751, 2.4751 right here goes with 68 degrees. And the cosine of some angle is 0.6428. So go to the cosine column, 0.6428. See where we get it at, 6428. Right here, 50 degrees. So this tells us that if we have a triangle, let me kind of sketch one here, kind of recap this a little bit. If we have an angle, and one of these angles is a right triangle, and one of these angles is 50 degrees, then we know that the ratio of the adjacent side to the hypotenuse came out to be 0.6428. So we would say cosine 50 equals adjacent over hypotenuse, and that is equal to 0.6428. So when you divide those out, you end up with 6428. So if we have 6428 in a right triangle, that angle must have been 50 degrees. Okay, let's look at number 15. We want to find the values of the variables, and so here we have some problems to solve. So let's look at the algebra that goes with this. So we have 38 degrees, and we've got an x over 46. So in relation to our 38, here's the hypotenuse. We have an opposite and an adjacent. X is opposite, A is adjacent. So we're going to say with opposite and adjacent, we have tangent 38 equals x over 46. Now, we want to get x by itself, multiply both sides by 46. 46 times the tangent of 38 is equal to x. So you need to go to the table, find tangent of 38 degrees. So here's 38. We want tangent 0.7813. So we're going to be doing 46 times 0.7813 and multiplying those together, and that's going to be our x. So I'll leave that for you to finish. Okay, I'm not going to do all of these. I'll just do, I'll kind of zigzag back and forth and leave these others for you to complete pretty much the same way, but these do need to be multiplied out. Let's look at number 18. Set that up. So you could have different ratios depending on the combination, sine, cosine, or tangent. Your x could be in different places depending on where it's missing. And one variation of this is if x is in the numerator, you're basically going to multiply both sides by the denominator. So, whatever the denominator is times sine, cosine, or tangent of the angle is going to give you your answer. Sometimes, though, we might end up with x in the denominator. Then it takes two steps. Basically, you're going to be doing the numerator divided by whatever the decimal is that goes with sine, cosine, or tangent. So we'll find one of those. So let's look at 18 here. We have n and 3n. Here's our angle, x. We want to find a value for x. N is here's the hypotenuse. So we have an opposite with a hypotenuse. That's going to be a sine ratio. So sine of x equals opposite n over 3n over hypotenuse. Now n over 3, and taking n out, we get 1 over 3, which is 0.3333 repeating. So we're going to go to our table, find the closest decimal to 0.3333, and that's going to be the angle that goes with the sine of x. So we're looking in the sine column for 0.3333. Here we have 3256, 3420, 3323. This is about 100 away. This is less than 100 away. It's closer to 19 degrees. So I'm going to say approximately 19 degrees. Now your calculator will give you a decimal degree, 19 point something. So x is approximately 19 degrees. Let's look at number, so you need to do number 16. Like if we set 16 up, we've got reference angle, this is opposite, this is adjacent, I'm taking this as a 5. So we've got opposite hypotenuse, that's going to be sine 55 equals 5 over 48. So you got to turn this into a decimal and then look it up in the table and find in the sine column and find the angle, or sorry, this must be x. So you're going to do 48 times the sine of 55, and whatever that comes out to be is going to be your x. Okay, let's do number 19. So 19, this is hypotenuse. With regards to x, this is adjacent. So we have, with numbers, adjacent hypotenuse. That's going to be cosine. Cosine x equals the adjacent, which is 8, over the hypotenuse, which is 12. Now 8 over 12 is the same thing as 2/3, which is 0.667, or 0.6667. So I'm going to go to my table, look up the closest thing to 0.6667, and that's going to be my approximate measure for x. So cosine column, 0.6667. So cosine is in the middle, 0.6667, 6691. This is the closest. It's about 48 degrees. Okay, let's do one down here on the bottom. Let's do number 22. So we got to find x and y. Now this is an isosceles triangle, 20, 20, 58. This is also going to be 58 over here, congruent base angles. And in this triangle, if we're using this 58-degree angle, this is an adjacent side. This is the hypotenuse. And this is opposite. So we've got, if we want to find out, say, what y is, we have adjacent with hypotenuse that we can use. Adjacent hypotenuse, that's going to be cosine. So we say cosine 58 equals adjacent, which is y, over hypotenuse, which is 20. To get y by itself, multiply both sides by 20. 20 times the cosine of 58 is going to be y. So if we go to our table and look up cosine of 58, so here's 58, cosine 0.5299. So we're going to be doing 20 times 0.5299. And whatever that comes out to be, that's going to be your y. Now to find the x, we're going to think about the x as being the opposite with the hypotenuse. That's going to be a sine problem. Sine 58 is equal to x over 20. So 20 times the sine of 58 is going to be x. And if we go to our table and look it up, looking for sine of 58, sine of 58 is 0.8480. So you have 20 times 0.8480, and whatever that ends up being, that's the value we have for x. So these others, you need to finish up pretty much using the same method on this.